Look at here, this is a copper cable. I will talk about the straight through. Here, first we need to connect this patch cable to the interface of this PC. This is the NIC port or Ethernet port. After that, we can connect it to the switch, for example, to one of its interfaces, gigabit Ethernet or a gigabit Ethernet of this interface. Look at here. In this scenario, I connected this port, the Ethernet port, with one RJ45 connector. Assume that this is the RJ45 connector. Okay, I connected this interface, this port, we can say interface or port, both of them are same, to one of these interfaces of this switch, for example, this interface. Okay, you will learn about the detail of this, but for now you can understand that how we are connecting one PC to one switch. Okay, look at here, we are connecting we are using one of this patch cord. In one side we have one RJ45 connected to this port, and in another side we have another another RJ45 connector, and after that we can connect this PC to the for example switch. Also, if you want to connect to two switches together, you can use two methods. The first method is using these patch cords for connecting two switches that is nearing to each other. For example, I am going to use another patch cord for connecting the switch 1 to switch 2. Assume that the switch 1 is the switch of one floor and the switch 2 is the switch of another floor. Look at here, I'm going to connect these two ports to each other, for example. Okay, and also if you want, you can use the fiber optic cable, as you learned in the previous part. With these ports here, you need to add one converter, again here one converter, and finally you can connect these two switches together with the fiber optic cable. Okay, because of that, now we can understand that we are using twisted pair cables for connecting the different network devices to each other. For example, we can use this twisted pair cable after attaching the connector RJ45 connector to these cables to creating these patch cords, and after that we can use this patch cord to connecting our PC to switch, or connecting switch to switch. Okay, switch A to switch B, for example. But we need to talk about another important information about the detail of the wires in this special type of cables, the twisted pair cables. We have some differences between the patch cord that we are using for connecting the PC to switch, and also some to patch cords that we are using for connecting to switch. Let me to write here the name of these two type of cables. After that we can talk about the detail. This is the straight, okay, a straight through cable. Okay, you will learn about the straight through cable, okay, after some second. And also here we are using another type of cable, we call it crossover cable. I'm going to talk about the difference between the straight through cable and the crossover cable. Both of them are the twisted pair cables, but we have some differences about the pinouts of these cables. Look at here in our simulator. If you want, you can see that here we have two type of Ethernet cable. The first is copper straight through. As you can see here, we have the copper straight through cable, copper straight through, and also we have copper crossover. Okay, I will talk about them. What is the difference between the copper crossover and copper straight through? After that, we can use these cables in all of our scenarios in this course. Alright, let me to start with one example. In this example, as you can see, we have two devices, device A and device B. It's not important which device we are using because the type of device is not important for us. Assume that in these two devices, okay, we have two port or two interface. For example, in device A, we have two interfaces. This is the first interface, okay, and this is the second interface. One of these interfaces are the interface for sending the data, or we call it the T interface or TX, okay, and another is the receiving interface. T is the abbreviation of the transmit or tip, and the R is the abbreviation of the receive or ring. Let me write here. T means tip and R means for example ring. If you want, you can say the for example transmit. T is abbreviation of the transmit, and R is the abbreviation of the receive. Okay, because of that, now as you can see, we have two devices. In each device we have one interface for send and another interface for the receive. Let me to show you here again. In this device, in device B, we have the same condition. The question is that how we can connect these two devices to each other, and finally we expect to these two devices can transport data, can transfer data between them, between each other effectively. Okay, how we can connect these two devices together? It's so easy. Let me to show you. Look at here. If you want to send data from the device A to device B, and device B should accept and receive the traffic, you need to connect the TX interface, okay, the TX interface to the RX interface of the other device. This means that the TX of the device A should connect it to the RX of the device B. Okay, it's obvious. And also we need to connect the RX of the device A to the TX of the device B. This is a crossover cable. This means that when you are using the same pinout in both devices, you need one crossover cable. In crossover cable, we are connecting different interfaces, different ports or different pins to each other. This is the pin 1 and this is the pin 2. Okay, also in the for example device B, we have the same pin out. Let me to write here, this is the pin out of the device B. Okay, because we are using the same pin out. This is the pin out. Okay, we need to use the crossover connection. This is a crossover connection, not only about the internet. This is always occurring that we have, when we have the same pin out in both devices, we need crossover cable. But let me to show you another two device. In these two devices, this is so important for better understanding the concepts in the for example network. Let me to show you again. We have two devices, the device A, okay, and also the device B. Again, we have this same pin out in the device A. Okay, in the pin of 1 and pin of 2, we are sending the traffic with pin 1 and receiving the traffic with pin 2, for example. But in the device B, we have the reverse pin out. For example, in device B now, the pin 1 is a pin for receiving the traffic, and the pin 2 is a pin for the sending the traffic. Okay, now we have this condition. How we can send traffic effectively between these two systems and also receive between these two systems? You know the answer. We need to connect pin 1 of the device A to pin B of the device, pin 1 of the device B, and also pin 2 of the device A to pin 2 of the device B. This means that we are using the straight connection. This is a crossover connection because we are crossing, and after that this is the straight or straight through connection. Okay, this is the foundation of our connectivity in the Ethernet LANs, straight through versus crossover connection. Okay, maybe you ask me, what is the relation between these two devices, device A and device B, and our devices? Let me to give you or introduce some of the devices that we need to connect these devices to each other in this course. For example, you know that we have the NIC. This is the simplest device that we are using, NIC or network, okay, interface card. You know that we are using the network interface cards for connecting our PC to the network. After that, we have some devices, we call them hub. You will learn about the hub. After that, we will learn about the switch. You know that we are connecting the PCs or some other end devices to each other with switch. Also we have router and some other devices, access point or some other. Okay, here we can see the name of some of the most important devices in the network. Also we have another devices, maybe you encounter with them in different type of the networks. How we can connect this different type of the network? I will give you some information about the devices. After that, you can better understand the issue that we have, and we need to solve this issue. Let me first say that you know that in the twisted pair cable, okay, in twisted pair cable, we have different types. For example, from Cat2, okay, let me write here from Cat2 to Cat8. In all of them, okay, we have 8 wires, or for example 4 pairs. You learned about it before. But let me to say that until the Cat5, okay, until the Cat5, we used only the 4 wire of this 8 wire. We used only 4 wire for sending and receiving data, and after that, for example, we can say 2 pair. The other pairs or other wires are were idle, okay? But today we are using all of these wires for more throughput, for more speed, for example. Let me to talk first about how we can use 4 wires or 2 pairs for sending and receiving, and this is the method we used until we reach to Cat5 or in sometimes in Cat5e. After that, we can talk about the Cat6 and for example newer standards. First, I'm going to show you how we can use 4 wire to send and receive or 2 pair, okay? We can use these 2 examples, but now I'm going to use 4 pins. As I mentioned before, we used 4 wire for sending and receiving in the Cat5 or below, okay? Again, here, let me to remove them. Here we have